Hello and welcome to another tutorial. We're going to continue our discussion with the very important topic of packages, fully qualified names, and class path. And we saw that we had this Java project which we set up in Eclipse, and we saw that how Eclipse creates, you have a source folder which you define your packages. These are just folders inside your source folder, src, and inside them you put your Java files, source files, and each Java file can have one or more class definitions. When the Java compiler compiles your source file, each class definition is compiled to a separate class file. And the way Eclipse organizes your project or the class files, the compilation, is that it creates a mirror it creates a folder called bin, which stands for binary. That's a very typical name. And then the class hierarchy, basically the folder hierarchy in the bin is exactly the same as your SCR, right, source. But then in the SCR you have the Java files, in the bin you have the class files, right? And again, the best practice was to only have one class definition in each source file so that you can get a one-to-one map. If you have more than one class file, then in your folder in the bin directory you have more than one .class file for a given source file, which is fine, right? And the idea was that whenever you use a type, whenever you say that my variable has this type, it just means that you're telling the compiler, hey, the compiler has to find a class definition on which corresponds to this type, here a string. And we said that if there's a clash of the names of the classes, then you have to either use the fully qualified name or use the import statement. So I can tell the compiler, so you have to somehow tell the compiler, give a compiler more information so that compiler has no ambiguity of which type you're talking about. I mean, that's the whole point, right? The compiler has to know how to correctly interpret your source code. So I can either use this. If I don't do this, then the compiler assumes this is part of the Java lang, which is by default always imported. So I can use the import keyword saying that this type is actually belongs to this package dummy, which belongs to this dev.java package again, right? And we said that the meaning of this is that this type, a string, is inside this dummy, inside this dev.java, and dev.java is the top level package, which has to be basically searchable or reachable through the class path variable, system property class path. When you launch your Java application, you have to point the class path to a folder. In this case, for example, it's not actually src. Don't make this mistake, because you have to tell the JVM where this dev.java package is that contains this type. And again, at runtime, type means the class file, .class, the compiled file, not the source file. So you have to actually point this class path to the bin directory, and that's what the Eclipse does behind the scenes, right? If I go back and look at the runtime arguments, basically working directory is dev.java, and then we have the main, a class, and then the project there, and Eclipse knows how to configure the class path correctly, right? And we saw that we can use the system property java.class.path to check the class path at runtime. When you run your application, the class path has already been set for your JVM, and in this case, when I hit right click, run as Java application, Eclipse IDE launches a Java application JVM and configures the class path. And then we saw that so let's open up a terminal here. So clear. So right now I open up a terminal in this OOP package or folder, right? In the src. Remember, if we are in the src, we are not in the bin directory, right? If I do a ls, you see that I actually previously compiled this class file. So I'm going to say rm classpath.class. So I'm going to remove this class file that we compiled. So what I'm going to say Java C. And remember, I'm using Java -- version. I'm using Java 15. It's part of my path environment variable. So Java 15 is my default. In Eclipse, I was using Java 16, but that's fine. So what I'm going to do, let's say, let's do ls. So we have this source file. I'm going to compile this source file and put the compilation exactly, the compiled class file exactly in the same folder, in the same location. So Java C class.java. And if I do ls, I have this classpath.class. But the problem in the last lecture was that when we say java.classpath, this means search for a class file, right? When you want to launch your application, you don't add the class, basically, let me zoom in. You don't add the dot class, you just say the class. But if I launch it, somehow Java says I cannot find it. The reason was that this class belongs to a package definition. This is very important. So this is the package definition, right? So then the problem was that it says that wrong name class path. It says that even though there is a class file here, it appears to have the wrong name. Why? Because if I go back to my navigator and this class that we compiled, right? If I open it with a class file viewer, there is a very, very interesting thing happens, and that's the thing here is that the name, the type, the name of this class is not class path, right? When the class, this source file gets compiled and a class file is generated for this class definition, the actual name of the class is the fully qualified name. That's why JVM is complaining I cannot find a type called class path, because that's not the name of the class. The name of the class is the fully qualified name. So in the bytecode or .class file, the actual name, basically the actual name of your type is the fully qualified, qualified name. And that goes into this concept of package declaration. So instead of saying class path, the actual name of your type is dev_java.oop.class path. And that's what this shows, right? In the source code, you wrote public class path, but in the bytecode, the name of your type is dev_java.oop.class path, which this is basically the actual name. And that's also the meaning of that import, right? Because the actual name of this type is not a string. It's basically Java dev.java.dummy.string, right? This is the actual name. But then the problem was that usually if you have many packages, typing this is very cumbersome and people don't like it, because most of the time you don't need to deal with the actual fully qualified name. The just name of the class is sufficient, right? So they decided to add this import capability. And what happens here is that at runtime or at compile time, you're telling the compiler, hey, this string, if I use a string by itself, it's a type. And then the compiler looks at your import statements and see this type matches which fully qualified name. In this case is this qualified name, and that's the correct value, right? So again, the name of your type in the compilation, after the compilation in the class file, it's not the name of the actual class that you use, it's the fully qualified name of the class. I want you to really understand this, right? Because again, in actuality, what you have to do, you have to always specify the fully qualified name. But we saw two exceptions. One, the types that are in the Java lang, that's because they get automatically imported, right? The other one is the types that are in the same package, because JVM already knows that what's going on, right? So in the, for example, this car, obviously this car is the same car and obviously the same class file in the, but for example, I can say cat, it's in the same package, my cat, right? This is fine, and I don't need to import the cat. I can explicitly import it, but there is no need, because the default behavior is that the type has to be, the type or the class file that is associated with this type has to be in the same package. Otherwise, you have to specify the fully qualified name if the classes or the types are in different packages. Again, the problem is that most of the tutorials that you see, they talk about the source, but we are talking about the class file, the compiled file, and behind the scenes some stuff happens. One of them is that the name of your class in the actual name in the class file is not the what you write in the source file. It's actually the fully qualified name. So in the source file, when you say class path, and your class has a package definition, in the class file, in the compile file, the name of your class is actually the fully qualified name. That's the most important concept that you have to grasp. Okay, now that we grasp this concept, the question is, obviously when we launch our application from our IDE, it automatically configures the class path. We don't need to worry about it. Then the question is, how do we solve this problem? So I compiled this class, and I have a class path.class in the basically in my current folder. So if I say let me do a ls again. If I say, now that I know that the name of the class is not actually the class path, it's the fully qualified name, I can say that dev_java.oop.classpath. This is the name, the actual name of this class, right, in the class file. So if I launch this, I still get the no class class not found exception. The reason is that now JVM basically we're setting up the name of the class correctly, but the class path is not set correctly, because now JVM expects to find a class, this class, from the class path point, and then the class path basically when I launch the Java, so when I launch like this is equivalent saying that the class path is the current directory. But then when the fully qualified name has packages, then the JVM expects to find this class file inside a dev_java folder inside the OOP folder, but the dev.java is inside the current directory, which is not, right? In the current directory, we don't have another directory called dev_java, and inside that we don't have OOP. So we have to change the class path. Again, this launching.java and then the fully qualified name of your class is equivalent to saying that -class path is the current directory. But that's not the case, because when you do this, then the JVM actually expects to find a .class file with this name inside this folder hierarchy. That's the meaning of packages. So we have to change our so if I launch this again, it gives me an error. So we have to launch this or set the class path so that JVM can find this folder hierarchy first. So we have to go 2 levels up. So this goes out of the OOP, and then the next one goes out of the dev.java. So this means go 2 level up, and then after that, when we launch this, the JVM searches for this class, fully qualified name, and then it finds this folder hierarchy, and then it finds a class file that associated with this type, right? Again, 2 important concepts, which is not talked about often about the class path, right? When you watch a tutorial. One, what happens if our class file or a class in the source file has a package definition? Then the important thing is that the actual name of your class, the type, again I'm using the keyword type here, the actual name of this type is not the class path in this example, it's the fully qualified name, dev_java.oop.class, but that's the package dot the actual name that you wrote in your source code, right? That's the name that actually is written in the bytecode as the name of your class. And we said that in actuality in your source code you should always use a fully qualified name, because that's what actually JVM understands. And because it's tedious, they added this import stuff. So when we use a property, the compiler and the JVM, the compiler knows that, hey, we're talking about the property that is inside this folder, that is inside the other folder, right? Inside this folder hierarchy or package hierarchy. It's easier than otherwise. We don't have to use this import, but we have to write the fully qualified name, java util. The reason is that the default package is the package that where the current class is, which is here. So for any other class that is inside the same package, we don't need to use the fully qualified name. For other classes that are not inside the current package, that are current classes, we have to use the fully qualified name or use the import keyword. So most people just use the import. The only exception is that when you have 2 classes that have the same name and you want to simultaneously use them in the same scope, in the same class file, then you can use one of them without fully qualified name, the other one with the fully qualified name, right? So this import is a byproduct of the fact that at runtime and also at compile time, the compiler and the JVM, both of them have to know where to find the class file, the compilation units, right? The actual bytecodes for different types. So when I launch this, I expect this to work, because now I'm telling the Java to set the class path to two folder up. In this case, it's going to go into the src, which includes my dev.java, and that includes the OOP, right? And then I'm telling it which class to run. And again, the mistake that people use, the encounter when they try to use classes that have package definition, is that they assume that they have to. So basically, one more time, if I say that, if I set my class path correctly, which is congruent with this package definition, but then if I try to launch this class file, right, this doesn't work, because in the name of the class is this class path, but JVM doesn't care of the name of the class, right? It cares about what the actual name of the type is, because it has to find the type first and launch the main method from type. So again, the name of the type is a little bit different from the name of the class file. The name of the class file is exactly the name of what you wrote for your class, but if the name of the file, the name of the type is the fully qualified name, which I wrote it here, right? So again, there is a distinction between the name of the class that you write in the source code, the name of the class file, your public class, the name of the class file is exactly the same name, but the name of the type, which what the JVM cares about, it has to find it, is the fully qualified name. So finally, the correct way of launching this main method for this particular class, which is called Classpath, is set the class path correctly. Set the class path correctly based on the package definition in your class definition, and then set the name of the class, or basically the name of the type, correctly. So we launch this, JVM starts from this folder, and then looks at the package hierarchy, and it goes inside this, and then this OOP, and then finds a class file with the same name. And now that it finds it, it can run the main method, and bam, we were able to finally launch our application, the main method. So let me go back again, let me go full screen. So the class path is set correctly. The name of the type that we want to run the main method is the fully qualified name, and it works fine, right? So again, be very careful, and basically be very careful about again, we don't need to again, this is something that people don't really teach or talk about, because when you start using an IDE, all of these are hidden from you. This kind of launching your Java application, just say right click, run as Java application. The class path is currently set, your IDE sets it. Each IDE has its own way of organizing your compilations, your class files, right? But the main concept again was that at runtime, JVM has to find the type. The name of the type is the fully qualified name in the bytecode, right? The name of the class file, the file that the Java compiler creates, is exactly the name of the public class in your source code, right? But the name of the type that the JVM searches for, and that's what the type of the variable is, right? A variable has a type, that type has a name. That name is the fully qualified name, including the package definitions. So you have to be very careful about the type and the class files and the name of the class in your source file, right? Be very careful. The default is that for the types in the same package, for example, cat is a type in the same package as my car class, right? Car type. For the types in the same package, you don't need an import declaration, and you don't need to specify fully qualified name. That's the default, which means whenever you write a type without fully qualified name, the compiler and the JVM, they assume that it has to be in the same package. But there is no limitation here. I could just say oop.cat. This works. You can always explicitly use the fully qualified name, but you don't have to. And again, the alternative to fully qualified name is to use the import statements. Import dev_java dot dummy dot cat, right? Not dummy, OOP. OOP.cat. So I am explicitly importing it, but the Eclipse compiler gives me a warning saying that this is really not necessary, right? So the import dev java OOP cat is never used, but we actually use this here But again, the compiler doesn't care about this import because that's the default behavior, that this cat has to be inside the same package, right? So use the import statement or the fully qualified name for the types when you're using types that are in other packages, right? Or in other libraries, whatever. Package only means that you are avoiding namespace collision or type collision, because again, the whole point here is that the name of the type, the package names are added to the name of the type in your class file in the bytecode. So whenever I have a string that is inside a dummy package, the name of that type in the class file is not a string, is package dot package dot the name of, this is the actual name of the type. So I want you to really grasp this notion. All right, that's the whole point, because now if I have a string in the Java lang, so if I have a string in Java lang dot a string, that's a type, that's a default built-in JDK string. Again, that's not the name of the type, is not a string, is Java lang a string. But because every class, every type in the Java lang is automatically imported, you don't need to use the import statement. But in reality, you have to use it. But they just made it easier for you to not use it. But again, JVM works based on the fully qualified name of the types, right? And then I have another type, Java dev.java dummy string. Again, the name of the type is not a string. The name of the type in reality, in bytecode, when you go down to very detailed, the name of the type is dev_java.dummy.string. This is the actual name of the type. So when I define a variable x, I have to explicitly write this type down. We said that this is tedious, so we have these import statements, and IDE can quickly help us with writing this down and automatically generating these statements. But in reality, you have to always use the fully qualified name, because that's what's written in the bytecode. In the actual bytecode, the name of your type of class is not a string, is dev_java.dummy.string. Again, be very cautious about this. All right, so let's quickly go through this. A package is a namespace, and this is a terminology used in C++, and we typically use it. And the whole meaning is that we are trying to avoid namespace collision, because the name of the package is appended to name of your type, which means that you can have the only time this reduces obviously the chance of type name collision, because this is one type, this is the other type. As long as there is no collision between the packages, then there is no collision between the name of the types, even if your class definitions have the same name, because the name of the type, again, it's not the name of your class, it's the fully qualified name, which means the package, the folders, name of the folders are appended to the name of the type when the Java compiler compiles your source code to bytecode, right? Be very careful about this thing. And then obviously the best practice is always try to use a unique name for your packages, at least the top level package, so that there is almost zero chance of collision. And what people recommend is to use reverse domain name. For example, if your company is some company, let's say mycompany.com, people recommend to start with com.mycompany.whatever, right? So people recommend to use the reverse domain name of your company or whatever entity you have, so that this uniquely identifies the codes, the source codes associated with your company. So this is one of the best recommendations or best practices. A package is a namespace that organizes a set of related classes and interfaces. And again, I'm going to go even more general and saying that a set of related types, because we had a detailed discussion about this. A type is a general terminology for class, interface, enum, anything, right? Any variable in Java has to have a type, and every type is identified by a separate .class file in Java. Even interfaces get compiled to a separate .class file. They don't compile to a .interface file, right? Remember, everything has to be .class. Conceptually, you can think of packages as being similar to different folders on your computer, and that's what it is, right? The only difference is that when you have a package declaration, your source code, the class file, the name of your type is the package dot the name actual class that you write in the source folder. You might keep HTML pages in one folder, images in another, and scripts or applications in yet another. Because software written in the Java programming language can be composed of hundreds or thousands of individual classes, it makes sense to keep things organized by placing related classes and interfaces into packages. And again, the main point of package or a namespace is C++. It's not really to organize, it's just being able to confidently avoid namespace clashes, right? You want to avoid collision between the type names, because if I don't append the name of the packages or folders to my types, I can never have two different types that have the name string, right? So packages and namespaces allow you to really avoid type name collision. Again, note that I'm not using the class name collision, I'm using the type name collision. So get used to this terminology. When I say type, it means any class definition, any interface definition, any enum definition, etc. The Java platform provides an enormous class library, which is the JDK, Java Development Tool Libraries, a set of packages suitable for use in your own application. And everything inside the java.lang, every type inside the java.lang will be automatically imported when you launch your Java application. That's why you never have to use the fully qualified name for those classes, for those types. This library is known as the Application Programming Interface, or API for short. Its packages represent the tasks most commonly associated with general purpose programming: strings, file IO, exception handling, network connection, this kind of stuff. These are the core API that the Java provides. For example, a string object contains a state and behavior for character strings. A file object allows a programmer to easily create, delete, inspect, compare, or modify a file on the file system. A socket object allows for the creation and use of network sockets. Various GUI objects like the Swing API, AWT, these are the graphical interfaces APIs that Java provides. Various GUI objects control buttons and checkboxes and anything else related to the graphical user interface. There are literally thousands of classes to choose from. This allows you, the programmer, to focus on the design of your particular application rather than the infrastructure required to make it work. The Java Platform API specification contains the complete listing for all packages, interfaces, classes, fields, and methods supplied by the Java SE platform. SE means a standard edition. Load the page in your browser and bookmark it. As a programmer, it will become your single most important piece of reference documentation. I mean, this is unnecessary. We're using Eclipse IDE. IDEs automatically load the documentation. So if I right click on my basically project and look at the resources, linked resources, linked resources, builders, coverage, Java build path, so let's see, Java code style, Java compiler, annotation, building, error, Java doc. So enable project, you can specify project specific settings for Java doc, and Java doc location path. Usually basically Java doc automatically comes, or the JVM. So if you see in the built-in documentation, for example, this is let's see, for example, this class is part of the core API for the Java. If I just hover my mouse, Eclipse automatically loads the Java doc for me, which is a very nice quick representation. And obviously Eclipse doesn't have the actual documentation. It's just probably it has the documentation in a jar file, in a zip folder, or it just goes to the actual website of the documentation and grabs the contents and runs it. And as you can see, if I click on this, it actually takes me the web page that contains this, right? So it actually goes to HTML rendered version of the Java doc, which is a nice feature. So the link that you see here, it's basically the same thing: docs.oracle.com/English/Java, Java SE base, and then you specify the version, and then docs API index.html. So this is a typical hierarchy. So docs.oracle.com, you specify the language, English, and then you want to look at the Java specification, and then Java SE, standard edition. Which version? 17. We can go, for example, to 16. Same story here, version 16 API. We can go to 15 API. The latest version is obviously 17, and then docs, and then API, and then index.html. All right. So I hope you enjoyed this lecture. Now have a very, very solid understanding of basically the concept of packages, class path, what is the fully qualified name, why do we have to use the import statements. And again, you don't need to use the import statement, but then you have to specify the fully qualified name for your types, and that makes life tedious. That's why we use these imports at the time. So please stay tuned, and I'll see you in the next one.